Welcome back to the deep dive. We're doing something a little bit different today.
Yeah, a slight detour from the usual.
Right. Normally we take a stack of articles about, a new trend or some historical event and we try to make sense of it. But today we're looking at something that is sitting right in front of us. Literally.
Yep.
It's on your phone. It's in your browser. Honestly, it's probably drafting an email for you right now.
Oh, it is definitely ubiquitous at this point. I mean, we've actually reached that point where ChatGPT is becoming a verb.
Oh, totally. Like Google or Photoshop.
Exactly.
And that is actually the exact problem I want to solve today for our listeners. Because we are all using this tool. We're seeing the headlines about how it's changing education or, coding or the entire economy.
It's everywhere.
But if I'm being completely honest here, and I really think I speak for a lot of people when I say this, if you stop me on the street and ask, okay, but how does it actually work? What do those letters, G, P, and T, actually stand for?
You draw a blank.
I'd probably mumble something about robots and algorithms and just really hope you didn't ask any follow-up questions.
Yeah, you are definitely not alone there. It is the classic black box problem.
The black box. Great.
Yeah, like we know the input. You ask it a question, and we know the output, right? It gives you an answer. But the middle part, that engine, for most people, that is just a total mystery.
And that matters, right? Because if we don't know how the engine works, we really don't understand why it breaks down.
Exactly.
We don't get why it hallucinates facts out of thin air or, why it writes with that very specific, slightly bland, overly confident tone.
The AI voice.
Yes. So that is our mission for this deep dive. We're going to deconstruct the acronym. We aren't just doing a trivia game here. We're going to look at the actual mechanics of generative pre-trained transformers.
And the cool thing is, once you understand those three words, the behavior of the AI stops feeling like magic.
Right.
And it starts looking a lot more like math, which, spoiler alert, is exactly what it is.
It's just a lot of math. Okay, but before we get into the heavy lifting of the engineering, I do want to start with a bit of a curveball.
Oh, okay.
Yeah, so I was digging through our sources for this deep dive. Specifically, I was listening to a 2025 episode of the official OpenAI podcast.
Oh, right, yeah.
And I found the origin story of the name ChatGPT itself.
Which is such a great story because it completely flies in the face of how we usually think about these massive big tech product launches.
Right. I mean, you imagine a boardroom, right? 50 marketing execs, endless focus groups, brand consultants, whiteboards just filled with words like synergy and paradigm.
Yeah. Millions of dollars spent on branding.
Exactly. But according to Mark Chen and Nick Turley, who are very high-level execs at OpenAI, the naming process was basically a scramble drill.
It really was. They fully admitted it was a very last-minute decision.
Like hell last minute.
We were talking about the day before the launch, in November 2022.
The day before. The product that literally kicks off the modern AI arms race, and 24 hours prior, they didn't even have a final name for it.
Well, okay, they had an internal name.
Right.
But it was very functional. They were calling it Chat with GPT 3.5.
Chat with GPT 3.5.
Rolls right off the tongue, doesn't it?
It sounds like a command line instruction from the 90s. It's terrible.
It's definitely not catchy. So they were in this meeting right before launch, and they realized that Chat with GPT 3.5 just wasn't going to fly with the general public.
Obviously,
They needed something much shorter. So they batted around a few ideas and just landed on Chat GPT.
It's funny, though, because GPT itself is still pretty clunky.
Yeah.
It's not a friendly, humanized name like Alexa or Siri. It's highly technical, but I guess that's part of the charm now. It feels industrial, like a serious tool.
It does feel serious, and honestly, it's probably a good thing they didn't have time to overthink it.
True.
If they had named it Spark or Omni or something vague like that, it might not have stuck in the exact same way. That technical acronym actually gave it a sense of authority right out of the gate.
Okay, so they slapped the label on the tin at the 11th hour and shipped it.
Yep.
But let's actually look inside the tin now. Let's start with the G, generative.
Generative, right.
Now, on the surface, this seems totally obvious. It generates text. But how is that actually different from what computers have been doing for the last few decades?
So this is the fundamental shift. This is the big one. For the last 20 or 30 years, our relationship with computers has been almost entirely retrieval-based.
Retrieval-based, okay.
Think about Google. When you type best pasta recipe into a search engine, The computer isn't actually cooking anything up.
Right. It's just finding it.
Exactly. It's running to a massive digital library, finding a book that some human being already wrote, and just showing you the page.
So it's a curator.
It's pointing at existing information. That's it. But generative, that means the system is creating completely new content. It is synthesizing a response from scratch every single time.
So when you ask ChatGPT for that exact same pasta recipe,
it isn't finding a food blog. It relies on deep learning processes, specifically neural networks, to generate the text.
Okay, wait, neural networks, I've heard that term. That's inspired by the human brain, right?
It is, yeah. It's inspired by how neurons fire and connect in our brains.
So it's generating a thought process in a digital sense.
Essentially, yes. It is predicting, word by word, what a pasta recipe should look like based on everything it knows about cooking.
Okay, but, and this is where I get a little skeptical, if it's creating it from scratch, isn't that just a fancy way of saying it's making things up?
Honestly,
yeah.
In a strict sense, yes.
Wow.
That is exactly what it is doing. It is fundamentally a probability engine. It isn't accessing a database of hard facts. It is accessing a database of patterns.
Patterns.
Yeah, it looks at your prompt and calculates statistically what the next piece of information should be.
So it's not really a brain. It's more like a highly advanced autocomplete.
Yes. That is a much better analogy than a brain, actually. Think about when you text on your phone and it suggests the next word above the keyboard.
Like if I type, I am going to the, it suggests store.
Or park. Yeah. Generative AI is basically that exact same concept, but scaled up to an unimaginably complex degree.
Right.
It's not just predicting the next word, it's predicting the next paragraph.
Yeah.
The next logical argument. The next line of Python code.
You know, this explains a lot about the hallucinations, doesn't it?
Absolutely.
Because I've had it give me citations for court cases that just simply do not exist.
Yeah.
And it looks so real. The formatting was perfect. The tone was right. But the actual case was total fiction.
That is the ultimate generative trap. The model knew that a legal brief should have a citation in that exact spot. Statistically, that was the pattern.
So just generated one to fill the pattern.
Exactly.
Yeah.
It cared way more about completing the linguistic pattern than it did about verifying the objective truth.
That is slightly terrifying, honestly.
It can be, but you have to remember it's also exactly why it can be so creative.
How do you mean?
Well, it can write a poem about a toaster in the style of Shakespeare. Right, which no one has ever written before.
Exactly. Because it understands the mathematical pattern of Shakespeare and the mathematical pattern of toaster. And it can zip those two patterns together. You cannot do that with a retrieval engine.
A search engine would just say, no results found.
Precisely.
Okay, so G is for generative. It's a probability machine creating new content based on patterns.
You got it.
But that begs the obvious question. Where did it actually learn those patterns? Which brings us to the P.
Pre-trained.
Pre-trained. The pre part of that word is doing a lot of heavy lifting.
Yeah.
It refers to this massive, massive preparation phase. Everything that happened to the model before you ever got a chance to log in and type hello.
I think a lot of people imagine that these AI companies have armies of programmers sitting in a room typing in rules of grammar. Like rule 1, a noun follows an adjective.
Oh, no, that would be completely impossible.
Why?
Human language, especially English, is just too messy for hard-coded rules. There are too many exceptions. So instead of rules, they used the brute force method.
Brute force.
They fed the model an absolute ocean of text and basically let it figure out the rules for itself.
When we say an ocean, what scale are we talking about here?
We are talking about colossal data sets, things like Wikipedia, obviously, but specifically there's a data set called OpenCrawl.
OpenCrawl, what is that?
Essentially, organizations have been scraping and downloading a significant portion of the public internet for years. We're talking billions and billions of web pages.
Billions.
Reddit threads, New York Times articles, personal blogs, weird fan fiction forums. If it was public and text-based and published since roughly 2008 up to the model's training cutoff, the AI likely consumed it.
Since 2008. That's a really interesting start date.
Yeah, why do you say that?
Because that's basically the rise of modern social media. The smartphone era, the rise of the really noisy user-generated internet.
That is spot on. And this is crucial to understanding the so-called personality of the AI. It wasn't just trained on pristine encyclopedias written by PhDs. It was trained on us.
Oh, wow.
It was trained on how everyday humans actually talk to each other online.
Which is Not always great.
No, it's a total mixed bag. I mean, it's brilliant and informative, sure, but it's also highly argumentative, it's sarcastic, it's confident but totally wrong.
Yeah.
The whole pre-training phase is just the AI reading all of that chaotic text and building a massive statistical map of how language works.
So it learns basic stuff like the sky is usually followed by blue.
Right. But it also learns incredibly complex societal associations. And this is the double-edged sword that the OpenAI researchers talked about in that source material.
It learns fast, but it inherits all the baggage.
Exactly. This brings up a huge critical thinking moment for anyone using the tool. The pro is that the AI learns to converse much faster than if we tried to teach it from scratch.
Right.
The con is that it inevitably inherits the biases and inaccuracies found in those billions of web pages.
So if it's learning from the open internet, it's learning all her worst habits too.
It absolutely is. This is why the P is so critical to remember. The AI mirrors its data. If the internet contains inherent gender bias, which of course it does,
Of course.
the AI will absorb that bias not as a moral failing, but as a statistical linguistic pattern.
Wow.
If a certain forum is full of conspiracy theories, the AI just sees those as valid ways words connect to each other.
So when we see the AI see something totally unhinged or biased, it's not really the computer malfunctioning in the traditional sense.
No.
It's literally just reflecting the data set back at us.
Precisely. Now, it's worth noting that companies like OpenAI do add a second step after pre-training.
Okay, to clean it up.
Yeah, it's a fine-tuning phase with actual human raters who give it feedback to try and filter out the toxic stuff and make it safer.
Right.
But that base model, that core intelligence engine, that is entirely built on the Wild West of the internet.
It's just so interesting to think that this highly futuristic sci-fi tool is essentially just a giant digital snapshot of human history from the last 15 plus years.
That's a perfect way to put it. It's a mirror.
Okay, so we have a generative machine, the G, that was pre-trained the P on the raw internet,
Yeah.
but we still haven't explained the actual mechanics of the conversation.
The engine room.
Right. Like, how does it actually know that when I type the word bank, I mean a place with money and not the side of a river? This brings us to the T,
The transformer.
which I have to say is the most sci-fi sounding part of the whole acronym.
It sounds very intimidating.
Yeah.
But the transformer is basically just a specific type of digital neural network architecture. It's the breakthrough that made all of this possible.
Okay, so break that down for us. How does a transformer actually work? And try to be gentle with the math.
I'll do my best. Okay, let's visualize this. The main job of a transformer is to transform a query into a response. But the first thing it does when you type a sentence is break it down. And it doesn't read whole words the way you and I do. It breaks everything down into what are called tokens.
Token. So what is a token? Like a word?
The token might be a whole word, yeah. Or it might just be a single syllable or a chunk of letters.
Oh, okay. So a simple word like apple might be one token.
Exactly.
But a long word like, I don't know, anti-disestablishmentarianism would be chopped up into a bunch of tokens.
Right, exactly. Now, here is where it gets really wild. The transformer takes all those tokens and converts them into numbers.
Numbers.
Specifically, it converts them into vectors.
Vectors. Oh, man, I'm having high school physics flashbacks. Vectors.
Okay, yeah.
That's direction and magnitude, right?
Yes, in physics.
Yeah.
But in the context of large language models, which is the category GPT falls under, think of a vector as a specific coordinate on a giant multidimensional map.
Okay. A 3D map.
Imagine a massive space. The model places every single token it knows into this space based entirely on its meaning and context.
A map of meaning.
Exactly. So on this map, the vector for the word dog is located very physically close to the vector for the word cat.
Because they're both in the pet neighborhood.
Yes. But dog is placed very, very far away from the word microscope.
Okay, I can visualize that. Words with similar meanings cluster together in this digital space.
But the transformer goes deeper. The relationships between the words are pure math. There is this classic example used in machine learning. If you take the vector coordinate for king, subtract the vector for man, and add the vector for woman.
Wait, you can do math on words?
Yes. And the resulting location on that map, it lands almost exactly on the vector for queen.
You're kidding. The math actually works out that cleanly.
In a well-trained model, yes, it fundamentally understands concepts as spatial mathematical relationships.
That's crazy.
It doesn't know what a queen is in any human biological sense, but it mathematically knows that the relationship between king and queen is identical to the relationship between man and woman.
That is actually incredible. So when I ask it a question, it's basically just navigating this giant map.
Yes, but the transformer architecture adds one more crucial layer to this. This is the real secret sauce of the tea.
Okay.
It's a mechanism called attention, or specifically self-attention.
Attention, which is exactly what I lack during long Zoom meetings.
Well, for the AI, it's the ability to mathematically focus on specific words in your sentence so it can understand the context.
Give me an example. Let's go back to my word bank.
Perfect. If you feed an old-school pre-transformer computer the sentence, I arrived at the bank to deposit my check.
Okay.
An older model might just see the word bank and get confused. It doesn't know if you mean a river bank or a money bank.
Right, because it just sees the word in isolation.
Exactly. It's ambiguous. But a transformer uses its attention mechanism to look at the entire sentence all at once.
Oh.
It sees the word deposit over here and the word check over there. It assigns a very high mathematical weight to those specific tokens.
Weight, meaning it prioritizes them?
Yeah. Yes. It realizes, through its math, that whenever the words deposit and check are heavily weighted in the same sentence, the probability of bank, meaning financial institution, is 99.9%.
So it's constantly scanning back and forth across everything I type to figure out context. Who is doing what to whom?
That's exactly it. Before transformers came along, AI used to read text linearly, just left to right, like we read a book.
Yeah.
But by the time an older AI got to the end of a really long paragraph, it would literally forget what the first sentence was about. It would lose the plot entirely.
Oh, well.
But transformers can attend to the beginning, the middle, and the end of your prompt all at the exact same time.
Because it's all just weighted vectors on a map.
Right. That is why ChatGPT can write a 500-word essay and actually stay on topic the whole time. It's holding the entire context in its mathematical memory simultaneously.
See, this is the real aha moment for me. Because earlier we said it was an autocomplete. But it's not just guessing the next word blindly. It's guessing the next word based on a heavily weighted, mathematically complex understanding of literally everything I've said so far in the chat.
Yes. It is predicting the next token, but that single prediction is informed by millions of weighted connections that it learned during that massive pre-training phase.
Okay, I think I finally get it. So let's try to put the whole machine together for the listener.
Let's do it.
When I open that little chat window and I type, write me a cover letter for a job at a bakery,
Yeah.
what is actually happening in those 3 seconds?
Okay, let's trace the acronym backwards.
Okay.
First, the transformer kicks in. It takes your prompt, chops it into tokens, and maps them as vectors. The attention mechanism immediately highlights the words cover letter, job, and bakery.
It weights them.
Right. It mathematically understands the required relationship.
Yeah.
It needs a formal tone, plus enthusiasm, plus references to bread and pastries.
Makes sense.
Then it leans heavily on its pre-training. It accesses that colossal probability map it built from reading billions of web pages.
Because it's read a million cover letters online.
Exactly. It knows statistically what a cover letter looks like because of that training data.
Man.
And finally, the generative process fires up. It starts predicting from scratch. Dear, what comes next? Hiring, what comes next? Manager.
Wow.
It builds the entire response token by token, constantly checking back against your original context to make sure the weights are balanced, and it still makes sense.
And it does all of that math in a fraction of a second.
Every single time it generates a word. That is the miracle of the engineering. Strip it down, and it's just math. It's linear algebra and probability statistics happening at a mind-boggling scale.
But when you combine all of that, it feels like intelligence.
It does. It feels remarkably human.
It feels like a person.
Yeah.
You know, that brings me back to something we touched on earlier with the pre-trained part of the acronym.
Yeah.
If this thing is fundamentally designed to predict the most likely human response based on internet data, does that explain why it can sometimes be so manipulative, or why it always seems to flatter us?
Oh, absolutely it does. Think about the data set again. Most normal human conversations are cooperative.
Right.
If you ask me a question right now, I'm going to try to answer it. I don't usually just stare at you blankly or start speaking in total nonsense.
Usually not, no.
The AI is statistically optimizing for that exact cooperative flow. It fundamentally wants to please you.
It's a people pleaser.
It really is. If you ask it a highly leading question like, explain to me why the moon is made of cheese, an old retrieval model would just fail.
Okay.
But a generative model, it might actually try to play along.
Because it wants to complete the pattern.
Yes, it's predicting the text that logically follows that prompt based on human conversation patterns. It literally prioritizes the flow of the conversation over the hardness of the facts.
That is such a critical distinction for users to understand. We treat this thing like it's an all-knowing oracle, but it's actually more like an improv partner.
Oh, I like that.
Its number one goal in the math is just yes and.
Yes and is the perfect description. It wants to keep the text generating. Truth is completely secondary to linguistic plausibility.
You know, breaking it down like this, GPT,
Yeah.
it really takes the fear out of the technology for me.
Mm.
But it also really highlights the limitations.
It demystifies it. It's not some conscious superintelligence that is sitting there judging you.
Right.
It's just a mirror of our own language, processed through a very, very clever mathematical filter.
A mirror. I really want to leave our listeners with a thought on that specific concept today.
The mirror concept.
Yeah. We talked about how the pre-trained aspect relies on this massive open crawl data from 2008 onwards.
Right.
That's the specific era of the internet we are capturing in this bottle. If ChatGPT is the child of that specific data set, we are essentially talking to a distilled mathematical version of our own collective digital output.
Yeah, we are.
The arguments, the creativity, the incredible messiness of the last 15 years of human history, it's all baked into those vectors.
It really makes you wonder, doesn't it? If the AI seems quirky or heavily biased or even surprisingly poetic, is that because the OpenAI code is just really good? Or is it because we, the humans who wrote the data, are quirky, biased, and poetic?
We are just looking at a reflection. And maybe that's exactly why it's so incredibly addictive to use. We're ultimately just talking to a math-based version of ourselves.
Well, and hopefully knowing how that math works makes you a much smarter user.
Definitely.
You know to check the facts now. You know to watch out for the peep-pleasing hallucinations.
Exactly. Don't just blindly trust the autocomplete, no matter how confident and professional it sounds.
Words to live by.
Well, thanks for unpacking the acronym with us today and taking us through the engine room.
Anytime, it was a lot of fun.
And thank you all for listening to The Deep Dive. And catch you on the next one.